This video is for the last lesson in Chapter 3. In class, we did page 19, the review and the reflect, so you should already have this written down. I've scanned my solution and posted it online on our My Math Lab website under Chapter 3. And now we're going to be on page 20 of our notebook. Before we start, take the 2 sheets of grids that I gave you, cut out each grid. On page 20, skip some space and tape 2 grids to the bottom right corner of your page. We're going to do 2 examples on page 20. Then turn the page. We're going to do 3 examples on the back of page 20, which is going to be an EX page. So tape 3 grids on the right-hand side of the page of the back. And then the last 3 grids will go on the next page. That will be another EX page. 3 grids down the right-hand side of that page. So go ahead and cut those grids out, tape them in, pause the video until you have that all squared away. You will also need a ruler for these notes or any kind of straight edge. And it helps if you have some sort of colored pencil. Any color is fine. It just helps if you have a colored pencil for these. So ruler and colored pencil, and tape in your grids. Pause the video until you have all of that done. So in our new textbook, this is section 8.4 on graphing linear inequalities. It's page 20 again of your notebook. Section 8.4, chapter 8. Section 4. To graph a linear inequality, the first thing you need to do is solve for y, keeping it to the left. You need your equation in y equals mx plus b form. That is your slope-intercept form. So your equation needs to be in y equals form. Once you've solved for y, keeping it to the left, you're going to have an inequality. You're going to graph that line using slope-intercept form. If your inequality has a line underneath it, whether it's less than or equal to or greater than or equal to, if it has a line underneath, you graph your line using a solid line. If it does not have a line underneath, if it's strictly less than or strictly greater than, you use what they call a dotted or a dashed line. So it's broken like the lines in the road when you're driving, when you change lanes, a broken dashed line. Anytime you need to pause the video to write things down, please do so. So you solve for y, keeping it to the left, put it in mx plus b form, graph the line using the slope and the intercept, and use either a solid line or a dashed line. Once you have your line drawn with either a solid line or a dashed line, you have to make a decision. You shade the graph above if it's greater than, or below if it's less than. I'm going to show you a technique that I use to decide above or below. The textbook uses something called a test point. So if the way I explain it does not make sense to you, go ahead and go to section 8.4 in your textbook and look up the idea of using a test point. I don't think a test point is necessary, but again, if the way I explain it does not make sense, you will need to learn how to use a test point to verify. Alright, those are the 3 steps. Solve for y, keeping it to the left, graph the line, either solid or dashed, and then we're going to shade with our colored pencil either above or below the line we've drawn. So let's look at some examples. Example 1. 3x plus 2y is greater than or equal to 6. Our first step, remember, is to solve for y. We're going to move the 3x to the other side. So we have 2y is greater than or equal to negative 3x plus 6. I want to put the x term first and then the constant. From here, we're trying to solve for y. We're going to divide by 2. Dividing by a positive number does not change that sign. So we have y is greater than or equal to negative 3 over 2x. And positive 6 divided by 2 is positive 3. So y is greater than or equal to negative 3 over 2x plus 3. Now we're going to graph this line. We're starting with the plus 3. The plus 3 is the y-intercept, so I'm going to put a nice clear point at the point 0, 3 for the y-intercept. From there I'm going to use the slope. The slope is negative 3 over positive 2. I always talk about keeping the negative on top. So from this point I'm going to count down 3 squares because it's negative, and to the right 2 squares because it's positive, and I'm going to put another point where my pencil lands. From the new point, I'm going to count down 3 squares over 2 squares to the right and put another point. Again, down 3 squares, 2 squares to the right, put another point. You want 3 or 4 good points all in a line. From there, I'm going to take my ruler, and before I trace my dots, before I make my line, I need to decide solid or dashed. This line underneath the inequality means we're going to draw a solid line. So once I line up my points, I'm going to draw a solid line all the way across my grid with arrows on the top and the bottom. So we have this line, and you need to draw it all the way across your grid to where it cuts your grid into 2 pieces. You have this little top triangle piece and this little bottom sort of triangle piece. So your line again needs to split that grid into 2 pieces. From here, your book talks about a test point. I'm going to show you a technique that does not require a test point. If you think about your line, again, cutting that grid into 2 halves, your eyes should be able to see above the line and below the line. If you think about writing your name on the line, where would you write your name? You'd write it on the top of the line. So this half of the grid is considered above the graph, and this is considered below the graph. Another way I explain that is if this pencil was my line, so my pencil's representing the line. If you think of the line as a seesaw, like 2 kids sitting on a seesaw, they would be sitting on the top of the seesaw. If you think about them sitting on this, and this is a seesaw going up and down, they're sitting on the top. So you have to decide which half of the graph is above the line and which half of the graph is below the line. If you can see that easily, you do not need to worry about a test point. If you cannot see that difference easily, then you'll have to learn how to use a test point. I like the above and below visually, and that's all you really need. Once you've decided which part of the line is above, or which part of the grid is above the line, and which part of the grid is below the line, then you shade based on the inequality. This inequality is greater than, that is saying y is greater than the expression, so we shade above the line. So you kind of take your colored pencil and you shade above the line. In my math lab, you take a little bucket of paint and you dump it or click it on the half you want to shade. So it's like the old school paint program from a long time ago. You draw your line just like normal, you decide solid or dashed, and then you dump a little bucket of paint above the line or below the line. In this case it would be above, so you shade every single ordered pair above that line makes the inequality true. So there's not just one solution, it's everything above this line makes this inequality true. Alright, we're just going to keep practicing. This takes some getting used to. If at any time you want to try one on your own, just pause the video and try it. So if you feel pretty good after that example, you can pause the video and try example 2. If you need to see it again, you can continue watching and see it again. So going back to the first step, I need to solve for y, keeping it to the left. Example 2 is x plus y is less than 5. To do this, I'm going to move my x to the other side. That leaves me with y is less than negative x plus 5. I don't need to divide by the coefficient because the coefficient is 1. So now I can graph. I'm going to start at positive 5 on the y-axis. My slope is negative 1 over positive 1. You always put it over positive 1 anytime you have an integer. So that negative is really a negative 1 divided by a positive 1. So from this point, I'm going to go down 1 and to the right 1. Down 1 to the right 1. enough times to where I can really see my line. Once I've done it enough times to see where I'm going, then I'm going to decide solid or dashed. Because this does not have a line underneath, it is dashed or dotted. You might see dotted. If it has a line, it's solid. If it does not have a line underneath, it is dashed or dotted. So I'm going to line up my ruler, but I'm going to make, again, think about the little breaks in the road, the little white stripes. I'm going to make kind of a broken line. So it's a dashed line. You want to make it very clear it's a dashed line. On your homework, you'll have the option to choose solid or dashed line. Then you think of that line as dividing your page in half. This is similar to example 1. You have to visually decide what's above the line and what's below the line. Like if you were to write your name, which way would be on the top? In this case, it's similar to example 1. This is above the line and this is below the line. So you just have to make that decision, and again, you can do that visually or you can use a test point. From there, I need to go back and look at my inequality. That says less than. It says y is less than the expression. So if it's less than, then I shade below. So every single ordered pair below that line, all of this space, all those ordered pairs will make the inequality true. So I shade below the line. That is it. I'm going to keep going with examples. There are a couple of weird ones along the way, but those are the basic 3 steps. Solve for y, graph the line, solid or dashed, shade above or below based on the inequality. So let's keep going with some more examples. Example 3, 3x minus 4y is greater than 0. If you'd like to pause the video and try this one yourself, I encourage you to do that. If you'd like to watch again, that's fine too. We're going to move the 3x to the other side. That gives us negative 4y is greater than negative 3x. I like to put the plus 0 to remind myself that my y-intercept is going to be 0. From this one, from here on this one, we're going to divide each term by negative 4. That is going to change my inequality. So it was facing, opening to y. Now it's pointing to y. It's gone from greater than to less than because I divided by a negative. So because that's negative, I had to change my sign. A negative 3 divided by a negative 4 is going to make a positive 3 over 4x. Then 0 divided by negative 4 is still going to be 0. Technically speaking, you don't need the plus 0. I personally like to put it, again, to remind myself that my y-intercept is at the origin 0. From there, I'm going to follow my slope of 3 over 4. They're all positive, so I'm going to go up 3 to the right 4. Up 3 to the right 4. And I can only do that a couple times, but I just need a few good points to see the pattern of my line. So I'll line up my ruler. From here, I need to decide solid or dashed. It does not have a line underneath, so it's going to be a dashed, broken line, like the lines in the road. Dashed line all the way across my grid. Some students will draw a solid line and then they'll go back and then erase and make some gaps. That's fine too. So if the dashing isn't working, you make a solid line and then just erase it a little to get the dashes. From here, I need to think of my line as cutting my grid in half. If I was going to write my name on this, this would be the top, that would be the bottom. If this was a seesaw, the kids would be up here and this would be the ground. So if you think of it again like a seesaw, the kids would be sitting on the top. Or if you think about writing your name on it, this would be the top. So this is above. This is below. Now I need to go back to my inequality. Because I divided by a negative, it changed. I can't make the decision until I'm in slope-intercept form. So up here it looks like greater than, but I don't know really until it's in slope-intercept form. This is now become less than, and so I'm going to shade below underneath my line. So again, you cannot make your decision until you're in the final slope-intercept form. I cannot make my decision from standard form because I don't know what's going to happen when I solve for y. In this example, it switched directions. All right, let's keep going. We've got example 4. 2x minus 5y is less than or equal to 10. If you have not done so already, I encourage you again to pause the video and try this on your own, and then play it so you can see how you did. We're going to move that 2x to the other side. That's negative 5y is less than or equal to negative 2x plus 10. Then I divide by a negative. Here's another example of dividing by a negative. Because this is negative, I have to switch my sign. Sorry, that got a little sloppy. Negative. It was pointing to y, now it's going to be opening to y. It still has a line underneath. That doesn't change. You just turn the direction of the sign. Negative 2 over negative 5 makes a positive 2 over 5x, and positive 10 divided by negative 5 makes a negative 2. So I'm going to go to negative 2 on my grid on the y-axis. From there, my slope is positive 2 over positive 5, so I'm going to go up 2. Right 5. I'm going to do that one more time, up 2, right 5 until I'm out of room. I need to decide solid or dashed line. If there's a line underneath, then I make a solid line. So I have a nice clean solid line here, all the way across the grid. It cuts the grid in half, so I need to decide above and below. It's very similar to example 3. This part is above the line. This part is below the line. And then I go back to my inequality. It says greater than, so I shade above that line. So this tells you the type of line, and then the inequality tells you above or below. All right, example 5. 4x plus 3y is less than 12. Again, I encourage you to pause the video, try this on your own all the way to the graphing and shading, and then see how you did. So we're going to move the 4x to the other side. 3y is less than negative 4x plus 12. Divide everybody by 3. The only time the sign switches is from division or multiplication, not from addition and subtraction. So we're dividing by a positive, and that's not going to do anything to the sign. So it's y is less than negative 4 over 3x, and then positive 12 divided by positive 3 gives you a positive 4. So the only thing negative here is the 4 on top, and I always put the negative on top so I don't mix it up. So I'm going to start at 0, positive 4. I'm going to move down 4 units because it's negative, and to the right 3 units. Down 4 units, to the right 3 units. I'm going to do that one more time. Down 4 units, to the right 3 units. As many times as I can before I'm out of space. Before I draw my line, I need to decide solid or dashed. It does not have a line underneath, so it'll be dashed. So here's my line. It's going to be dashed. Broken little pieces of a line all the way across your grid. It cuts your grid into 2 pieces, so you need to decide above and below. Think about if you wrote your name on this line, where would you write it? Up here. So this is above, this is below. And that's just a visual decision. If you're having trouble with that, look in your textbook about test point. You have to decide above and below. It's just a visual decision. Then we come back over here. That is the less than sign. If it's less than, we shade below. It's every single place below that line. And on your homework, it's just you kind of click your paint bucket above or below your line. All right, just a few more examples here. Here's one more in standard form. Go ahead and try it on your own. Pause the video, try it on your own, and then we've got two special cases. So example 6, I'm going to move that 2x to the other side. That gives me y is greater than negative 2x plus 2. No division necessary because y already has a coefficient of positive 1. I'm going to start at positive 2 on the y-axis. My slope is negative 2, and I'm going to put it over positive 1. So from here, I'm going to go down 2 units to the right 1 unit. Down 2 to the right 1, down 2 to the right 1, down 2 to the right 1, as many times until you can see that line forming. You need to decide solid or dashed. There's no line under here, so we're going to have a dashed line. So line it up here, make a broken dashed line. All the way across the grid, it cuts your grid in half. This is pretty steep, but still think if you were to write your name on the line, this would be the top and that would be the bottom. So we have above and below. Then we come back over here, it says y is greater than the expression, so we shade above that line, everywhere above that line. So above and below has nothing to do with the axes. Just kind of pretend the axes aren't there. I know that makes it a little confusing, but if you kind of ignore the axes, you're just focusing on this line above and below that line. It has nothing to do with the actual x or y axis. All right, now a couple special cases here with vertical and horizontal lines. They always like to break the rules. So example 7, you'll notice it does not have a y variable, it only has an x variable. And example 8, you'll notice only has a y variable, there is no x variable. So when you notice that there's only one variable, you have to solve for it. So in this example, we would solve for x by adding 3 to both sides. That's the inequality x is less than 4. Then we're going to have to graph that line. Now you have to remember vertical and horizontal lines. If it's an x equals value, it makes a vertical line. So I'm going to go to x is 4 on my grid, and it creates a vertical line at the x value 4. It's dashed because it does not have a line underneath, so we're going to make a dashed vertical line at the x value 4. I got a little bit off there. So you have a dashed line, it's vertical at the x value 4. Now above and below on a vertical line are just positive and negative. So to the right of a vertical line is bigger, and to the left of a vertical line is smaller. So the right side is considered above, and the left side is considered below. It's only based on the x values. These x values are above 4, these x values are below 4. So it's nothing to do with the vertical, it's just right and left. This says less than, so we're going to shade under positive 4, below positive 4, which is just to the left of positive.